The very first thing that we did yesterday at the beginning of this unit is we noticed that if you have a difference of squares and you multiply two conjugates together, the shortcut is that it's just the first one squared minus the second one squared. And why this is so helpful is because if you square a square root, it goes away. So if I could multiply by the square root of 5 minus the square root of 2, the bottom would just become 3. So I want to rationalize this denominator. Again, we can only multiply by 1, but you're going to want to multiply by this number 1. So that your bottom, all the square roots would go away. And I introduced to you this definition already. We can highlight it again. We call the same binomial with a different sign in the middle the conjugate. And so when we multiply by this number 1, what ends up happening? The bottom just becomes 3. And when we multiply it out and distribute it across the top, we get root 15 minus root 6 all over 3. So if we have a single square root on the bottom, it's easy to multiply by that same square root to rationalize the denominator. But if you have more than one square root on the bottom, or if you have a binomial with a square root on the bottom, you're going to have to multiply by the conjugate. And they have that also in the box at the bottom. All the conjugate is the numbers are the same with a negative sign in the middle. So we go to example 4 here. And we get this nice complicated word now that says simplify, which now means a whole bunch of things. Okay? It means everything from before. So fractions in lowest terms, combine like terms, combine like radicals, right? Radicals as mixed radicals in lowest terms, and no square roots on the bottom. That's a lot to remember in simplify. And I won't be able to tell you that on a test. You can't go, what does this mean again? Am I done? Well, you have to know what it means, and you have to know when you're done. So it's complicated that way. So for this one, 4 plus 2 root 6 and 3 root 2 minus 4. I have a square root on the bottom, so that's not allowed. I do a quick check to see if any of my square roots could be simplified even further, but none of them can get reduced down further. So I'm going to start by multiplying by the conjugate. So when we multiply by the conjugate, this is the big idea. If you can recognize that when you have a difference of squares, just like this will be a difference of squares, and I have to put the same thing on the top because the green has to equal 1. Because multiplying by 1 doesn't change what the answer is equal to, it just changes how it looks. I can put brackets around this and brackets around this. And we're going to have to FOIL everything out. Now on the bottom, we can do the shortcut. We know since it's the difference of squares, it'll be the first one, all squared, minus the second one, all squared. And on the top, I'm going to have to distribute. So 4 times 3 root 2. Boy, there's a lot of things to remember. Remember how we multiply radicals. We multiply the numbers in front, so 4 times 3 is 12. And then we multiply the radicals, but there's only the one radical, so it just stays 12 root 2. Then 4 times 4, that's easy, that's 16. 2 root 6 times 3 root 2, well, 2 times 3, that's 6. And root 6 times root 2, that's root 12. And finally, 2 root 6 times 4, 2 times 4 is 8. And I just have the one root, so it's just 8 root 6. Are we done simplifying? No, I can square things on the bottom. And the whole reason we multiplied by the conjugate was for this reason. 3 squared is 9. Root 2 times root 2 would be root 4, which is just 2. This will become 9 times 2, 18. Minus, and 4 times 4 is 60.
Would we need the absolute value bar in the?
You wouldn't need to, because when you square 2, it's still, and it becomes, and you square 2 and you get 4, and then you square root 4, you just get 2, and it's positive already. The fact that I wrote 18 as a positive number, we only need the absolute value bars when it's a variable, and we don't know what that variable could be. But when it's a number, we don't need the absolute value because you just have to write the positive value down. Good question. So now, on the top, do I have any like terms? No. Are there any square roots you can simplify further? Yes, I'm going to circle it here in blue. This is the only one. The rest, none of them are like terms. I still have 12 root 2. I still have plus 16. But this 6 root 12. Can you see that in the square root of 12? Oh, your mental math skills will get tested in this unit. You have to recognize that 12 is 4 times 3. And you can do the square root of 4. So I can pull out, I'm going to put a plus sign here. If I take out that square root of 4, that square root of 4 becomes a 2. 2 times that 6 in front becomes a 12 root 3 plus 8 root 6. Okay? So on the top, no like terms, and all my radicals are reduced. On the bottom, do I have like terms? Yes. 18 minus 16. So I'm like, okay, just rewrite the top. I rewrite that whole top just to write divided by 2. Is this in lowest terms? No. Because do you notice that this 2 on the bottom means every single thing could be divided by 2? Could every single thing be divided by 2? Yes. What's half of 12? 6. What's half of 16? Can you do half of this 12? Yes. Can you do half of that 8? Yes. So we get half of 12, 6 root 2. Half of 16, 8. Half of that 12, 6 root 3. And half of this one, 4 root 6. Whew. This is completely simplified. And you might look at this whole thing and feel like, it's just as complicated looking to me as it was at the beginning. And I don't know, all that work actually makes it seem more complicated than it was at the beginning. If I could have just left it at the beginning, I'd be much happier. But this is what we're going to be expected to do. We have to get good at our skills of working with square roots. And mathematicians have made these rules about simplifying. And part of simplifying rules are there so that if 2 different mathematicians were working on a problem in 2 different places, they wouldn't get into arguments where one would say, oh, I solved it. I got 6 root 2 plus 8 plus 6 root 13, 6 root 3 plus 4 root 6. And the other guy said, oh, no, you must be wrong because I got this. And they're like, that's the same thing. So they made rules for simplifying, so when we're discussing things in simplest form, everybody should have the same answer. Question?
How did you get rid of the 8 minus 16?
This 18 minus 16?
Yeah, how that can go to 2?
What happens if you take 18 and you subtract 16?
Oh.
I love it, right? This is the beautiful thing about, we get into such complicated math that sometimes something as simple as like, how do you do 18 minus 6? Like, how did that become 2? It's like, did you use some advanced fancy calculus for that? And sometimes we miss some of those easy things, right? But that's okay. That is what's happening in your brain as we're doing these complicated things, okay? Your brain is going to be struggling with the complicated things, and sometimes it's going to play tricks on you and say, oh, by the way, just for this moment, you're gonna forget your middle name. You're like, why can't I remember? Because your brain is working so hard on other stuff. You're gonna forget simple stuff that you like, I always used to know what that was, and now I just can't remember. Okay. I'll draw a line so we can do part B right to side. Again, I like to simplify my square roots if I can to begin with. So I do a quick check. Can I simplify square root of 3? No. Can I simplify root 6? No. Root 2? No. Root 3? Even though the answer is no, I can't simplify them, it's still not bad to do a check. Okay? I do have square roots on the bottom, and I do have a binomial. So I have to use the idea of a difference of squares to get rid of that. So I'm going to multiply this by, on the bottom I would have to have 3 root 2 and 2 root 3, but because it's a plus sign, this time I need to subtract. That makes a difference of squares. I'll put that in brackets. I'll put these in brackets. And of course, I have to multiply exactly the same thing on top. So the reason we do that is so that we can get the difference of squares. It will be my first term, which was 3 root 2 all squared, minus my second one, which was 2 root 3 all squared. You don't have to use the shortcut. You can actually distribute and FOIL and multiply all the arrows. You'll always notice that your outside and your inside with the difference of squares cancel out beautifully and just disappear. And that's why the shortcut is nice. On the top, though, we do have to multiply things out normally. So remember, how do we multiply radicals? Take the numbers in front and multiply them. So 2 times 3 would be 6. And the square roots, the root 3 times root 2, we multiply the radicands, the insides. So I'll get 6 root 6. Then 2 root 3 times the negative 2 root 3 will be negative 4. And I'm okay if you would have written 12 right away. Okay? Sometimes your mental math, you'll be like, ooh, I want to think ahead and do a little bit of mental math and recognize that root 3 times root 3 is just 3. And then 3 times 4 is 12. If you wrote 12 there right away, fine. Next one, negative 4 times 3, I'm going to get negative 12. And root 6 times root 2, root 12. And finally, negative 4 times negative 2 is plus 8. Wow, ugly plus sign. Plus 8, and root 6 times root 3 is root 18. Part of the reason I wasn't too worried about not writing the 12 when I had the 4 root 9 is because I know that we're going to still have to do a bunch of simplifying. So in this next step, I may as well simplify this. If I square 3, I get 9. 9 times 2, this will be 18. If I square 2, I'm going to get 4. And then square root of 3, squared will just be 3. So 4 times 3, 12. It's going to get some complicated math on the bottom again, right? Now, on the top, we have 6 root 6. And then I can change this to 12 now. Ooh, do you notice that both this one that I circled in blue and this one that I circled in green can be simplified? Because 12 is 4 times 3, and 18 is 9 times 2. So, if I pull out that 4 and make it a root 3, the square root of 4 pulled out becomes just a 2. 2 times that negative 12, negative 24. Square root of 9, if I pull that out, so it just becomes a square root of 2. The square root of 9 becomes a 3. 3 times 8 is 24. So 18 minus 12 is 6. And on the top, you notice that none of them are like terms. None of them are like terms, we can't put them together. So now we have to ask, is this in lowest terms? No. We're dividing by 6. This means each term gets divided by 6. Can each term be divided by 6? Yes. Now sometimes you might get something where, let's just pretend one of these, instead of a 24, was just a 3. If this last one, that's 24, was just a 3, they'd all be divided by 6 except for the last one. It's only divisible by 3, if that was the case. But then you'd have to say, well, everything can be divided by 3 then, and you take out a 3 out of everything and leave a 2 on them. But in this case, everything does divide by 6, so when I divide the first one by 6, I get root 6. Minus 2 plus 4, oops, that's not plus 6. Minus 4 root 3, oh, I lost the 9, plus 4 root 2. Everything divided by 6. Whew, I should circle. My final answer has no square roots on the bottom, has no square roots that can be simplified further, it has no like terms. This is as simple as it gets. And it doesn't matter if you have multiple terms like this, it doesn't matter the order that you write them. Okay, please try 10 and 13. Try those two, will take 5 minutes right now.